Processing offers us lots of different types of variables, each one designed for a different task. Ints hold integer numbers, floats hold floating point numbers, color variables hold colors, and Booleans hold true and false values. The basic idea behind a Boolean can be thought of as nothing more than a lie detector. You just hook the thing up and you ask it a question, and out comes a reading, true or false. And those are the only answers. Let's use the lie detector analogy to look at the question, is a less than 5, for some integer variable a. Here's the lie detector strip, and I'm going to ask this question for lots of different values of a. So the first value is a equal 2. Is a less than 5? Yes, it is. No surprise, and so we'll mark that as yes. How about a equals 3? Is a less than 3? Well, yes, it is. A equals 4. Is a less than 4? You bet. So that's also yes. Now a equals 5. Is a less than 5? No, it's not. It's equal to 5. So the answer to the question now is no. And when a is 6, a is also not less than 5. So the answer is no. We could absolutely call these results yes and no, as I've labeled them here, and some languages do. In processing, we label yes as true and no as false. So the results of this question are either true or false. And those are the only answers that can come back from is a less than 5. Those values get stored in a variable called a Boolean. So where does this word Boolean come from? It's in honor of a mathematician named George Boole. And George Boole worked out a lot of the basic ideas behind logic that are used in computers. In his honor, the type of a variable that can hold the value true or false is called a Boolean. To declare a Boolean, we just declare it with type Boolean, like we would declare an int or a float, and we give it a name. And I'll call this one A5 test, because we were testing if A was less than 5. So this little name is meant to remind us that that's what it was for. A Boolean variable can have only one of two values, true or false. True and false are special things. They're keywords. They're not numbers. They're not colors. They're not floating point numbers. They are the word true and the word false. And those are the only things that can be put into a Boolean. Let's actually look at a piece of code with Booleans in it. Here's a very simple sketch. I don't even have a draw routine. In the first line of setup, I declare a Boolean variable called isTrue, and I assign it the value true. Then I declare a variable called isFalse. It also has type Boolean, and I give it the value false. And now I just print them out. Print isTrue equals, and then I use the plus to glue things together. IsTrue, and I do the same for isFalse. So let's run this and see what these variables are. And I hope it's no surprise that isTrue is true and isFalse is false. These aren't strings, they're not numbers, they're the words true and false. I'll show you how Booleans hook up to functions. Let's pass a Boolean into a function. I'll make a very simple function that just prints out the value of the Boolean it's given. So let's write that function. It doesn't return anything. I'll call it print bool, and it takes one argument, a Boolean, which I'll simply call b. And we'll just say b equals b. So all print bool does is take a Boolean as an argument, and it prints it out. So let's go ahead and call that on our two variables, is true and is false. So we're handing it Booleans. Let's run it and see what we get. I made the output window a little taller here so we could see it all. Is true and is false are just what they were. And we have b equals true and b equals false because we're calling the function twice. So that worked great. Finally, let's see that a function can return a Boolean. I'll write a silly little routine. I'll call it return bool, and it returns a Boolean. Doesn't take any inputs, and let's just say that it returns true. And now let's go ahead and use it. I will print something out. Value from function equals, and then I'll just call the function, return bool. And if I run this, you'll notice that the output we get is true because that's what we're returning. As a final subtlety, let's return a variable rather than the actual value. So let's call this retval for return val. So I'll declare a Boolean called retval. I'll assign it the value true, and then I'll return the variable. And this will have exactly the same result. It returns true because the variable is true. So Booleans are just like anything else. We can hand them to functions. Functions can return them. We can assign them to each other, and we can assign values to them. But the only values that they can be assigned are true and false. Booleans are the key to all the testing we do in processing because every test is going to be true or false. So Booleans give us a way of saving the results of a test so then we can later use it to decide what we're going to do. You'll find a Boolean either explicitly as a variable or implicitly in the form of a test in every single if statement you ever write.